So we're going to be looking at the predicting of products for single replacement and double replacement, or single displacement, double displacement reactions here. Now, single replacement, whether or not this reaction is going to happen depends upon the activity series. And this is what we did in lab the other day. And when you look at an activity series, the elements at the top are more active than the elements at the bottom. And typically our activity series lists metals, but also includes hydrogen because we look at how these metals react with acids a lot of times. So you can notice again at the bottom we see our jewelry and coinage metals, copper, silver, platinum, gold, because those are very non-reactive metals. We don't have coins in our pocket and when they get wet, explosion. So how this works is any metal, any element that is above another element can kick that element out of a compound. So we will see a reaction. If it's the other way, we won't. So I'll reference how we saw in lab the other day. So let's look at our examples. This is from our note sheet. So lithium reacting with hydrochloric acid. Lithium is Li, hydrochloric acid, HCl. Can lithium kick hydrogen out of the acid? That's the big question. So when we look at our activity series, lithium is way more active than hydrogen. So yes, lithium can kick the hydrogen out of the hydrochloric acid. So lithium will kick the hydrogen out, and then lithium will get together with chlorine, which of course we know as lithium chloride. And so the formula for hydrogen, part of Hofbrinkel, H2. And then from our super friendly ion card, we know that lithium is +1, chloride is -1, and so lithium chloride is LiCl. Because of our good buddy H2, we're going to have to balance, so I have to put 2 hydrogens in, but that makes 2 chlorines, so I have 2 chlorines coming out. That makes 2 lithium, so I put 2 lithium in. Alright, next example. Sodium and silver phosphide. Can sodium kick out silver? Well, when I look at my chart again, my activity series, sodium is still pretty active. Silver's way down there. So yes, sodium is going to be able to kick out silver. Sorry about that. So yes, sodium will kick out silver, and sodium will get together with phosphide. Alright, now let's check the next one before we write the formulas in balance. Magnesium and potassium carbonate. Can magnesium kick potassium out? And so we see magnesium is here, potassium is above it. So there is no way that magnesium is going to kick out potassium. It was like in lab, if I put a piece of magnesium into, say, potassium sulfate solution, we're not going to see any reaction. And so that is indeed no reaction. So we don't want to waste our time, quote unquote, writing formulas if we know that no reaction is going to happen. Take a second, pause the video, and see if you can write the balanced reaction for number 10, and then I'll show you the answer. So hopefully this is the balanced reaction you got, because silver on our friendly ion card is always +1, and so is sodium, and phosphide is -3. So because of that, I have Ag3P and Na3P. And so I need the 3's in front of the sodium and silver to balance that. Now, our halogens will also take part in these single replacement reactions. And as they're listed on the periodic table, fluorine is at the top. It is the most reactive halogen. Then chlorine, then bromine, then iodine. So fluorine can kick out any one of its relatives. Iodine cannot. So when we see a reaction like this, fluorine plus sodium chloride, can fluorine kick out its family member, chlorine? And as I just said, yes. So chlorine gets kicked out, and then sodium and fluorine get together, which we know as sodium fluoride. Down here, can iodine kick out bromine? And as we just talked about, no. Iodine cannot kick out any of its relatives, so that will be no reaction. If we had had fluorine or chlorine here, then yes, it could have kicked bromine out. Now, pause the video, take a second, see if you can write the balanced equation for number 12. So hopefully you've got this balanced reaction. And again, from our super friendly ion cards, sodium is +1 on both sides, chloride and fluoride are -1. And so fluorine and chlorine are both part of Hofbrinkel, and that's why we have to have the balance that way. All right, now double replacement, double displacement reactions. In order for those to work, we have to see one of these three things formed. A molecular compound, usually water, a gas, bubbling, or a precipitate, that if you remember, is a solid that forms from two liquids mixing. We've seen that in lab before, and actually the week-long lab that we're going to do, we're going to see a lot. It's all based on double replacement reactions and forming precipitates. So don't worry right now. As far as the quiz is concerned, all the double replacement reactions I give you will work. Just focus on checking to see whether or not single replacement works with the activity series. But for double replacement reactions, these are the square dancing change partners. Silver nitrate reacts with potassium chloride. So what we see is that the outies get together, as do the innies. So switch partners, we're going to make silver chloride and potassium nitrate. Aluminum sulfide and calcium bromide. Switch, you'll get aluminum bromide and calcium sulfide. Take a second and see if you can do this one. Ammonium chloride plus zinc phosphate. What are you going to make? You are right. You're going to get ammonium phosphate and zinc chloride. So now what you have to do with these buggers is you have to go through and find the ions and write the formulas in balance. The nice thing is when you find the ion charges on the left-hand side, the same ions are on the other side. So on my super friendly ion card, silver's always +1, so it's +1 on the product side too. Nitrate, polyatomic, -1, it's -1 as a product too. Potassium +1, chloride -1, potassium +1, chloride -1. These are all +1, -1s, so I can put them all together. Silver nitrate plus potassium chloride makes silver chloride plus potassium nitrate. All right. Pause the video, see if you can write these two correctly balanced, and then I'll show you the answers. So number 15 here, you can see the charges above all the ions, and here was an example where I had an odd even number of bromines, 2 bromines going in, 3 bromines coming out, so I had to fix that by doubling, and so hopefully you got that correct balanced equation. Down here, ammonium chloride, +1, -1, so NH4Cl. Zinc phosphate, 3 zincs, 2 phosphates in parentheses. Ammonium, +1, phosphate -3, so 3 ammoniums in parentheses, 1 phosphate, +2, -1 for zinc chloride. So this one is a challenge, but I usually like to fix the polyatomic ions first. 3 ammoniums coming out. If I put a 3 here, that's okay, but now I have 3 Cl's. I have 2 Cl's over here. So that's not going to work. That's my odd even scenario. I need to double my recipe. So I'm going to make 6 ammoniums go in. 6 ammoniums, so I have to put a 2 here to make 6 ammoniums. That makes 6 chlorines. So I'll put a 3 here to make 6 chlorines. Cross your fingers. 3 zincs, that's good, 3 zincs. 2 phosphates, 2 phosphates. so that's balanced. Alright, so hopefully that helps with single replacement and double replacement predicting products and writing the balanced equations, and you're going to do wonderfully on the quiz. See you later.